Assalamu alaikum everyone. Welcome to today's program for unit number 7 of our database systems course. Our today's topic is structured query language. This is one of the most important topics in this course. SQL is the standard language used to communicate with relational databases. Let's explore what SQL is, what it can do, and how we use it in practice. SQL stands for structured query language. It's important to note that SQL is not a general purpose programming language. Instead, it's a domain specific language, meaning it's designed for a particular kind of data called structured data. Structured data is the type that follows the relational model where data is stored in tables and relationship exists among entities and attributes. So SQL provides us a standardized way to define, manipulate, and query this structured data. SQL statements can be categorized into three main types. These are data definition, which is used to define and modify the structure of the table, structure of the database, such as creating tables, deleting tables, altering tables. So for the purpose of creation tables, we use the command create table. For modification in the structure of tables, for example adding some columns, deleting some column, we use alter table commands. And for deletion of a table, we use drop table statements. The second one is data manipulation, which is used to handle data inside tables. These statements are used for managing the actual data inside the tables. With data manipulation language, we can insert, update, delete, or retrieve records. For the purpose of insertion, we can use insert into commands. For the purpose of selection or getting data, we can use select statements. For the purpose of updation of data, we can use update statement. And for deletion of records, we can use delete from. Data administration, the third option is, which is used to control access and manage user permissions. For example, granting some permission or revoking these permissions. All of these are expressed as SQL commands or SQL statements. Now that we understand the different types of SQL statement, let's discuss what SQL can actually do in practical terms. SQL is the interface between us and the database. Every time we talk to the database, we do it through SQL commands. The first thing SQL can do is execute queries against a database. This means we can ask questions such as show me all students enrolled in the BScs program, or list all employees whose salary is greater than 90,000. These questions are expressed in SQL using the select statement. Then SQL can retrieve data from the database. Retrieval means we are reading existing data, not modifying it, just viewing it. For instance, select name, department from employees. So we are basically selecting two columns which are names and department from the table employees. SQL also allows us to insert new records into a table. Suppose we just add a new employee, we can add that record using insert into employees. Values are employee number 105, name Sarah Khan, department finance, and the salary 65,000. So insert into tells us in which table we are going to insert these records, and values tells us the exact data we are basically inserting into. Once data is stored, we often need to update it. For example, when a student changes their address or a product's price increases, that's done using the update statement. And finally, SQL can delete data. For example, removing old or incorrect record using the delete statements. We will use the syntax for each of these later in this unit. So this group of functions, querying, retrieving, inserting, updating, and deleting, is what we collectively call data manipulation in SQL. SQL does not stop at manipulating data, it also gives us full control over the structure of our database. We can use SQL to create, modify and manage the database objects themselves. For example, SQL can create new databases. For the purpose, we use the statement create database and its name. Its name can be, for example, we are creating database for university use, we can give name create database UniversityDB. Once the database exists, we can create table inside it. For the purpose, we can use the statement create table, its name, then its columns, then its data type. For example, we are creating a table namely students. For the purpose, we can use create table students, then its columns student ID, then its types integer, then name the second column, its type variable character and its length. That's in this case we can give 30, 40 as per our requirement. So SQL can also create stored procedures. These are small programs that store business logic inside the database. These are useful for tasks that need to be repeated often, such as generating reports or processing payrolls. For example, create procedure get all students as select static from students. So we are basically selecting all the records of students and then creating their grades. Another capability is creating views. Views are basically virtual tables generated from queries. A view does not store data itself, it simply presents data from one or more tables in a particular way. For example, we are creating a view using commands create view, its name is active students, as select name program from students where status is equal to active. So we are basically selecting all those students names and program which are active in students table. Then finally, SQL allows us to set permissions on table, procedures and views, meaning we can decide who is allowed to see or modify certain data. For instance, a database administrator might give teachers read-only access to student records but prevent them from deleting data. So SQL is powerful because it operates at two levels: the data level, which is basically inserting, updating, querying, etc., and the database structure level, creating tables, creating views, granting or revoking permissions. So together these make SQL the backbone of the relational database system. Now see how we actually start working with SQL in a practical environment. The very first thing we need to do is create a database. This is done with the create database statement. For the purpose, we can use create database keywords, then the name we want to give the database. For example, if we want to create a database for college, we can create using the command create database collegedb. After creating it, we must select that database to make it active for our next command using use collegedb. Think of create database as creating a folder and use as opening that folder to start working inside it. The syntax might vary slightly depending on which SQL platform you are using, MySQL, SQL Server or Oracle, but the logic remains the same. Once the database exists, the next step is to create tables, or what we call relations in relational database terminology. The general form of the command is create table keywords, then table name, and in brackets list of columns and their data types. As shown on screen, we are creating a table namely students. Its columns are student ID, which is for the type integer, then name which is basically variable character, and its length. In case of characters are variable, especially for the case of variable characters, we should define the limit or size of that name of that column. So the third column is, or attribute is program, which is also a variable character of the length 30. Each column has a name and a data type. If later you decide that a table is no longer needed, you can remove it completely using the drop table statement. For example, in the case of the previous example, we can use drop table students, but be careful. Once dropped, the data and structure are permanently removed. In a table definition, the most basic element is an attribute, also called a column. Each attribute must be assigned a data type that defines what kind of values it can store. The most common data types include int or integer for numeric values without decimals. Then the second one is real or float for fractional numbers. The third one is character for fixed length text, for example, character with length 10 always reserves space for 10 characters. Then the variable character, we should define the size of variable character. Using variable character is more flexible and memory efficient, while character can be faster when every entry has the same size like postal code or IDs. Choosing appropriate data type is crucial for performance and data integrity. Now let's focus on an important concept, which is keys or primary keys. In a relational database, a key is an attribute or a set of attributes that helps us uniquely identify each record or row in a table. Without keys, our tables could easily end up with duplicate or ambiguous data. The most important key is the primary key, often abbreviated as PK. A primary key serves as the unique identifier for every table or row in a relation. This means two things: uniqueness and non-nullability. Uniqueness means no two rows can have the same primary key value, and non-nullability means the primary key can never contain a null value, because the null means unknown and we can't uniquely identify something unknown. There can be several candidate keys in a table. Candidate keys are those which can be a primary key, which can uniquely identify all the records. For instance, both student ID and roll number might uniquely identify students, but we choose only one of them to be the official primary key. Other candidate keys that are not chosen as the primary key can be declared as unique keys. They also enforce uniqueness but allow one null value. Here is a simple example. For example, create table students. Its columns or attributes are student ID, which is an integer with primary key. So here is a simple example. For example, we are using create table, namely students. So its first column is student ID, and we want to declare it as a primary key. So after its name, we should mention its type. Its type can be integer or variable character. So in this case, we are declaring it as integer, and then primary key, the keyword. So this keyword shows that there can be some other attributes, but the primary key should be student ID. So there is another attribute, that is roll number, and we give its type variable character of the length 10. We can mention the unique attribute with this. We can left it without unique, then it can't be unique. But in this case, the roll number can't be repeated, but it can be a null value. This ensures every student has a distinct student ID and roll number, but primary keys and unique constraints are fundamental to maintaining data integrity and avoiding redundancy. Sometimes a single column is enough to uniquely identify each record. For instance, in a banking system, each branch has a unique name. As in the given example, create table branch, and the attributes are branch name, which is a character type, it's a primary key. Then the branch city, which is also a character type, and the assets, which is an integer type. In this table, branch name acts as the primary key. What does that mean practically? It means we can't insert two rows with the same branch name. If we try, the database will throw an error like duplicate entry for primary key. This automatic enforcement of uniqueness is one of the most powerful features of relational databases. So primary keys are not just labels, they form the backbone of relationships among tables, which we will explore further when we talk about foreign keys in later units. Let's consider a slightly more complex case when no single column can uniquely identify a row. In such situations, we can define a composite or multi-attribute key. Let's take the example of a table named cells. Its keys are, or its attributes are bar, which is a character type. Another key is price, which is a real type, and then we give primary key keyword. Its mean primary key. After giving primary key in the bracket, we should mention the name of the columns, bar and price. Its mean, no combination of two bar and beer can be the primary key. Bar and price can be a primary key. Here neither bar alone nor price alone is unique, but together they make a unique combination. So if a bar sells Pepsi, that specific combination bar and price will appear only once. If the same bar sells another brand, it's fine because the key combination changes. For example, courses and students, doctors and patients, or products and suppliers. Remember, a primary key can include more than one columns as long as together they ensure uniqueness. We have created tables. The next step is to query them, that is, to retrieve and display information. SQL provides a simple, powerful and flexible way to do this using the select statement. A typical SQL query has the following structure as given: select customer name, city from customers. So customer name, basically we are selecting two columns, customer name and city from the customer tables. So in this situation, the records of all the customers and their cities will be displayed. This is sometimes called the query skeleton. Almost every SQL query follows this format. So let's break it down. The select class specifies which columns you want to see. The from class tells the database which tables to retrieve the data from. The where class filters the result based on condition. Think of it as select these columns from this table where certain conditions are true. This is the foundation of data retrieval in SQL. The select statement is the art of SQL. It allows us to fetch data stored in one or more table. For example, if we want to retrieve customers' name and their cities from a customer table, we write select customer name, city from customers. This will return a result set or table showing only those two columns. In the given example, we can use select static from publisher. Its mean. Basically, we are saying all the records of publisher table. When we use select, we are asking the database to return all columns from a table. It's convenient when exploring data but not recommended in production queries because it can be efficient and may expose unnecessary data. This query, as given on the screen, retrieves every record and every field from the publishers table. In professional practice, it's better to select only the columns you actually need, such as select publisher name, city from publisher. Select the columns we required. For example, publisher name or state from publishers. Or the second thing, we can use the where clause. This keeps queries clean and improve performance. Now explore an important refinement to the select statement, that is select distinct command. By default, SQL returns all matching rows from a table even if they contain duplicate values. But sometimes we are only interested in unique entries, and that's where distinct helps. For example, suppose our customers table look like this: name, country, product type. So our primary key is basically with the combination of name and country. The first customer is Ali from Pakistan. Its product type is, for example, electronics. The second customer is Noman, which is from Bangladesh. Its product type is cloth. The third one is Nazia, which is also from Pakistan. So when we use the command select country from customers table, normally it's return as Pakistan, Bangladesh and Pakistan. But when we use select distinct country from customers, then it's return as Pakistan and Bangladesh only. So in such cases, the duplicate values will be left alone. SQL distinct can be used in those cases which we use only unique values. You can also use distinct on multiple columns, as in above. We can use distinct with name and country also. This will give you unique combinations of country and names. So distinct is very useful when you are summarizing or analyzing data to avoid repetition. Thank you very much for your attention and participation. In the next program, we will discuss the where clause. Allah Hafiz. Thank you.